part 3 of chapter 6. So let's talk about how asteroids and comets form or where they form exactly. So asteroids and comets are the leftover of the accretion process. For whatever reason, they didn't end up to be in the part of the planet. So rocky asteroids were form inside or accrete inside a frost line or a snow line. And so icy comets that are mostly ice plus dust particles form outside of the frost line. So we have evidence of heavy bombardments, which are, so these leftover planetesimals bombard the objects in a late stage of a solar system formation, so about 3.9 billion years. So when we were going and studying the craters of the moon, we can see that their age is a little bit different from the rest of materials on the surface of the moon, or even on Earth. So some of them dated back to 4.5 billion years, some of them dated back to 3 billion years, 3.9 billion years, which means that heavy late bombardments happened. So that is probably the reason that we have oceans on Earth. Earth formed in a region of the solar nebula that was too close to have any liquid water survive on its surface. Since these comets are more than 90% ice, and the most abundant ice is water in them, there's a theory that says, okay, probably the late heavy bombardments caused these comets to bring their water and their ice with other element that formed to the Earth. So that's why we have oceans on Earth. That's one of the theories that we have in astronomy. But we cannot really still explain the odd things that we see in our solar system. Why the rotation axis of Uranus is tilted that way? Why do we have a very large moon compared to our size? You know, when it comes to moon, there are two different ways that a planet can have a moon. You can either capture a moon, so that's a small object. Usually, when we're talking about small objects, we're talking about kilometer-sized objects. So probably about 1 kilometer to several tens of kilometers. So this is one of the ways that most of the planets in our solar system capture moon, okay? Like Pluto, like Uranus, like even Jupiter. So a object is coming, it eventually ended up being trapped in the gravity of a planet, and so it started rotating around it. And that's called capture moon. The other way that we can have a moon is through a very giant impact, and this is what we think happened to our planet. So a Mars-sized object, probably another planet, had a catastrophic collision with Earth. So in a matter of few hours, all of these materials were just, these debris were shattered everywhere. They eventually end up going all the way and covering everything. Some of them rain back to the surface of Earth, but then some of them remain out, and so they eventually accrete to form the moon. And I'll show you a video. I'll upload a video for you later, so you can kind of look what I'm talking about. But this is the best theory that we have so far that explains why we have such a large moon. So the odd rotation of Uranus, we still think that it's caused by another giant impact. So the giant impact might cause the severe change of the rotation of some of these planets that we see. Now, let's talk about a question. So again, when you get to this point, please pause the video, read the question yourself, read the answers, and wait a little bit, and I'll go over the answer with you shortly. Okay. So how would the solar system be different if the solar nebula had cooled with a temperature half of its current value? Okay. So whatever it is, just make it half. A is Jovian planets would have formed closer to the sun. B, there would be no asteroids. C, there would be no comets. D, terrestrial planets would be larger. So pause the video, And guess what the answer is? The answer is that Jovian planets would have formed closer because when you have a colder temperature, the frost line would move, right, closer to the central star. So the Jovian planets, which are now a composition of ice and dust, are forming closer to the sun. Another thought question. Which of these facts is not explained by nebular theory? A, there are two main types of planets, terrestrial and Jovian. B, planet orbits the same direction and plane. C, asteroids and comets exist. D, there are 4 terrestrial and 4 Jovian planets. The answer is D. We don't really know why we have 4 terrestrial planets and 4 Jovian planets. That is unexplainable with this theory. All right. Now, we go to our last part of this chapter. So we want to know when these planets form. So we cannot find the age of a planet itself, but we can go ahead and grab a sample, bring it back and study it. So we can determine the age of the rock through careful analysis of its isotopes. And one of these isotopes that we usually look for is potassium-40. Why? Potassium-40 can decay to argon-40, okay? And so the lifetime of it is 1.25 billion years. In other words, if you have a sample of potassium, just potassium-40, 1.25 billion years later, half of it has been decayed to argon. Okay, so start with 1.25 billion years later, you have half of potassium remained, but half of it is now argon-40. So if you carefully go and examine these ratio of these isotopes, you can find out the exact portion of them, and then so you can move the clock back to see this starting point. Okay, this is what we've been doing for the rocks that we have found in meteorites. So the age dating of the meteorites that are unchanged since they condensed early in the solar system time can tell us that the solar system is about 4.5 billion years. So the reason that we know the solar system is 4.5 billion years is because we have grabbed the asteroids sample on Earth, and so we studied them, and so they dated back to 4.5 billion years. So radiometric dating tells us that the oldest moon rocks are 4.4, some of them are 4.55 billion years, and so probably the planets form about 4.5 billion years. All right, this is the end of chapter 6, and the formation of the solar system, end of part 3. All right, stay tuned for next chapter. We'll talk soon. Let me know if you have any questions, okay? Take care.